Yo, what's good, gang? Recording the video. See, now my camera's too low. What the bruh. Oh, fuck, I almost knocked over my drink. Okay. Welcome back. Shout out GitHub followers. I love followers on GitHub. Gotta make the Pokemon sound of the day. Today is Nidorina. I'm guaranteeing that 99% of people who are watching right now do not know what the fuck this Pokemon is. And that's valid. Because this one's kind of forgettable. But let's hear what she sounds like. Shall we? Okay, let's get one more listen. Need out. All right. They're getting less embarrassing by the day. I'm like pretty stoic on about it now. I don't really feel it. All right, let's get into the Leetcode of the day. Isn't that exciting? How exciting? Dude, it is 6:40 a.m. and it is pitch black outside. The sun needs to come up. You know what I'm saying? Oh, let me sign it on the other monitor. Okay, never mind. It didn't matter at all. I'm not gonna lie, guys. I peeked at the problem today, and it was seeming kind of easy. So, let's see what we got. All right. So we got, you are given a root of the binary tree and a positive integer k. All right. The level sum. Like it's just level order. It's like you may as well just. I mean, I would probably use a heap for this. I would use a max heap for this. But yeah. All right, so let's do a max underscore heap equals, I mean, this is like, okay, hold on. If not root, return 0. All right, q equals dec root. Yesterday's problem was kind of tricky, so hopefully this problem is, well, I guess I'm not asking for an easy problem, but, you know. Also, like, I feel like I should be explaining how to do these while I do them, because, like, to help me prep for interviews. But I'm just so tired when I start these videos. Like, I have to kind of get into it, you know, that I don't want to do any of that. I'm just trying to sit here and kind of code, and I don't know, maybe that's bad, but, you know, who knows. All right, total plus equals. I mean, if someone is watching this and they kind of, because I know a couple people follow along with like only the Leetcode part. If you like really want me to explain some of these problems as I do them, I'll do them because I kind of need to. But if you'd rather just see me like kind of go through it and struggle, or like do it like as you did it, that's cool too. Because the problem is like I can't really explain them when like I've never done them. Like I can, right? But I mean like there isn't much value in me explaining it if I don't know what I'm doing. I'm not teaching you. Like I'm just doing it myself for the first time. You know, I'm probably like wrong most of the time. So. Get this out of my way. Max underscore heap. Does this work first try, guys? What is this supposed to return? 0 or like, is it -1? Yeah. Okay. If I probably should do this before. I'm just put this somewhere. Right here. That way I don't have to heapify it, because it's like, that's a pretty long operation. This is one of my easiest problems by far, bro. Medium. This isn't easy. I'm not even joking. This isn't easy. Sorting. See, people sorted it. I want to know how fast mine is using a heap instead of sorting it. Now I gotta read some of the comments, see what's good. 269. This guy's a grinder. Damn. See, this is a good, I think this is a good, look, he has, he's top 20%, but he only has like 260 problems solved. Hold on. So, what is this? Jewel leak coding challenge. Is that July? Can I look where he works? C++. That's based. This page is... Alright. Yeah, me IRL, bro. Except it's not funny when you say it. It's only funny when I say it. This problem should be marked easy. Today's my birthday, but no one wished me. This guy sent proof of his date of birth, bro. What? Is this like a translate thing? What is this guy saying? Alright. Easy level question. I mean, he's kind of right, bro. This was definitely easy, bro. Like, come on. Discussion tab is kind of trash now. No, it's not. Oh, see, people did use a heap. 650? What's my... doesn't tell me, dude. But here's the thing, right? Let me show you guys something really interesting. Oh, it's gonna do the thing again. Oops. Let me just show y'all something really quick. I want to lock in for this. Well, I guess I can just show you my submissions thing, but I'll do it here. Yes, I know what I'm doing, guys. Don't you worry. I know exactly what this looks like, okay? I know what I just did. Don't worry. Okay, well, it's like bugged out right now. But if you... I've done this problem so many times. Okay, beats 33. Bro, I've had like... Hold on. Look. This is a real binary search implementation right here that I did. Beats 7%, and it's somehow slower, bro. It's somehow slower than this one. Look, 195, which is a what is this again? Is this linear search? Which is 195, and this is 202 with binary search. Like I'm just like messing around here. Look, 183 with linear, 186 for binary search with the recursion version. Like, I'm not gonna lie, like the bug with the 100% is kind of annoying. But dog, like, I'm not gonna lie, it doesn't do anything. It's like fucking useless. Okay, this is nlog n. Let's analyze it. It's nlog n though. Wait, is it nlog n? Is it n times nlog n? It's m times nlog n. Oh no, because it's h. It's amount of levels. So hold on, so n equals nodes in tree. H equals height of tree. If I did a linear, well, I just like looked at every node once, and then I looked at the height of the tree. I sorted that. So it's n times h log h. N times log n. Cap? No, it's not. Yeah, it's just not, because my heap will always have less than this. Oh, but it can be a binary tree can be a linked list, right? So I guess technically that's not true. Okay, yeah, technically, and okay, that's come on, bro. That's some BS, bro. Let's comment so I can get some engagement. Like if you agree, and for good luck. Let's bold it. I don't know what I'm doing, bro. All right. What do I want to do right now? I need to work on the project. Is what I need to do. Oh man, I'm tired. 2:34, bro. I got my interview on November 22nd. Yeah, let's get started on this project. I'm gonna do more Leetcode later for sure. Because I need to. Dude, I also need to do like the learn CPP thing. Keep forgetting. Nah, I'm not forgetting. I just don't have time. I have to go to class at like 9 a.m. You know what I'm saying? 9 a.m. That's early as fuck. Like, I'm trying to sit home and do nothing. You feel me? You feel me on that? No. Yo, if anyone is still watching, I forgot to do the sound for... You couldn't hear the sound, I just realized. For the Pokemon. Yeah, because I had the sound off. Okay, in the comments, I'm probably gonna like put a timestamp right here. But here was what it sounded like. You can go back and compare my my impression. This is the one right here. Let's listen to that one more time, just for fun. Terrible. Abysmal. All right, I'm gonna mute it again. The problem is sometimes I like to listen to music, you know, and I obviously can't have it playing like that. So, but we're building a little bit of a music player. Isn't that fun? What did I do yesterday? I make it like my latest commit. How do I look at my latest commit? Thank you to whoever started. You're the GOAT. Bro, I need to like learn how to use GitHub. Move scroll bar. Okay. Okay. All right. Let me open up like Spotify, like UI. Um, you know what I need to do? So I have all of the things. I have all of them saved in this folder. I need to somehow like be able to read this folder and like display it, maybe. Maybe I don't know. I have no idea how to do that. Is that what I need to do next, do you think? Like, who is you? I need a playlist tab on the left. Your library. Yo, underrated feature though. Um, this like Spotify. I use YouTube Music. All right, guys. My mom pays for premium. I use YouTube Music. All right, it's better anyway. The feature of like them having uh like AI choose what song is next in the queue instead of like some stupid like some rudimentary algorithm is so much better. By the way, because then actually play songs you like. And like people, I think when they found out like you couldn't turn it off on Spotify, they were like complaining like, dude, I want to listen to these songs. You know, I will never play certain songs in a playlist. Like, bro, you don't like them. You don't even like those songs. You know what I'm saying? Like, bro. All right. So I'm going to make a library thing on the left side. Probably going to make... Pow. Okay, nice. So I need a thing on the left here. So I need another VBox probably. I'll probably need a new file for that. Library. Yeah, I want to do this, but I want to do it inline. How do I do that? Man, it's actually crazy. I've been like coding pretty like consistently for like the past like couple like I want to say like 4 or 5 months. This type of stuff is still so hard for me. Like, how do I do this? I wonder when I'm gonna get past this hump. If I'll ever get past this hump. I'm not gonna lie, guys. I drank a Celsius, and I have a lot of energy, but at the same time, I'm tired. You feel me? What am I doing? I think I'm on the spectrum, guys. It's empty. It tastes so good, though. Okay. All right. Okay, I need like a paint thing. All right. Okay, I just need to have it display your library and then just like playlists. That's all it needs to do. Okay? Well, we'll do some placeholders. I don't need this stupid paint thing. What am I? Okay. So I need a text thing. Hold on. So let's do a private VBox. Do I need to import this? Why is that not allowed? There we go. Okay. What do I have to do again? I have to get deadly. How do I get deadly? Wow, dude, I'm just really just sitting in front of this editor and I'm just struggling. It's because it's IntelliJ and IntelliJ is ugly. I lied. It's actually dope. Okay, I need a text thing. Okay, private. Is it label? Label. playlists. I need an array of playlists, right? How do I make an array of playlists, dog? Or a list? I need an array list. Or do I make a VBox inside of a VBox? How would I make? Fuck, dude. The design decisions of this. Here's the issue I'm struggling with, right? So I'm going to have this text box here. I'm not going to have this. I'm not going to have this search thing. I might later. But I need like songs, right? It's going to be playlist 1, playlist 2, playlist 3, playlist 4. And the issue is like, how do I want to structure this? Like, is this an array? It is, right? It's an array of playlists. Do I need a playlist object? Would it be better to have a... No, it would definitely be better to have in a playlist. And a playlist object is an array list itself of media objects. But that's it. Yeah. All right, let's make a playlist object, bro. Jesus. I hate Java. I lied. I'm okay with Java. It's just freaking hard. Is it me? Is that it? Is that all a playlist is? I think so. I need some like public. I don't know. Dude, I public. I mean, maybe they should be public, but maybe not. Because then I can just do all the, like, I don't want to rewrite all the array list methods, you know? I'm going to ask, I don't want to ask ChatGPT, bro. I'm so reliant on him, bro, for ideas. Kind of need to go to the bathroom. Private array list media player songs. Now, what would I need in a playlist though? Like, I don't know what I want. Like if I have a method like get all titles or get all songs, it's like that's just the array list. Right? I can just like loop through the array list. But it'd be good to have my own playlist object because then I can put the same thing everywhere, right? Okay, I gotta go to the bathroom. I'll be right. Bro, I won't even lie. I just went to the bathroom and something terrible happened in the bathroom. You get what I mean? Okay. I was thinking about it while I was in the bathroom. How I want to do this playlist object. Because the problem is, not the problem, but if I just rely on the array list methods, that's not cool because the array list methods are not specific enough. Like we need like a public void add song. That's what we need. Right. Is this maybe not a... This is just a song object. Let's rename this. Can I make it a prototype? No, you can't, because this language sucks. Oh wait, you probably can. What? Okay. Songs. And they should not be called songs. They should be called playlist. Playlist dot. See, the problem is I just have no idea how Java array lists work. Here we go, bro. How do I add some items? That's it. Oh, I need to, whoops. Public playlist. Is this how I do this? This feels wrong. I'm gonna ask ChatGPT. if I have a Java class with a constructor, that's it. So I was right. Yeah. Okay. So remove object O. Can I just do that? And Java will just handle it for me? Yeah, bro. Dude, this is why Java sucks. I'm just sitting here doing the biggest boilerplate ever. Like I'm not even coding. It's like shoot. How do I do this? Public song get song. What am I doing with this method? Do I need it in here? No, I don't. How do I do enhanced for loops? What? Mediaplatters.getI. What is this guy talking about? What? The set on end of media. What the fuck? What? Dot set on end of media. Yeah, sure, dude. Sure. End of media. Yep, that makes sense. But why can't I just do it in here? Oh, and I should initialize it to 0. That makes sense. I'm really struggling with this. Play next song. Wait, isn't that a function? I just don't know if this works or not. Dude, this guy's a troll. I don't like this at all. This is a terrible way to set this up. Public void play. If get size is greater than index. And playlist dot get at current index dot play. What is this dot? Set an end of media. Yeah, I'm just really struggling with this. This is crazy. Man. That's it, right? Song.java. Who told you to do that? What the f... Yo. How do I get rid of this git shit? Can I do a constructor inside of a constructor? I don't think there's a reason to. Media. Hit. Can't do that. Can you... Okay. Let's see if that works. It should play it immediately. Okay, it did. Now I have to... Okay, in theory, you guys can't hear it because I don't want copyright, but it's working right now, is all I can say. It did play the next one. The audio is off. Yo, just so you guys know, that's how loud it is. I can't turn it on because I'm gonna get copyrighted, but it's my ears, drums are blowing, are dying. Okay, so that play all function is working, and now I'm going to move on to some Leetcode. I'm not gonna lie, this was really hard, but I feel like I'm kind of getting the hang of it. Kind of, not really. I'm lying. I'm like lying right now, maybe, but you know. Okay. Now it's time to do some more Leetcode. I don't wanna. The fuck is this? Oh yeah. This is wrong. That's right. Dude, I don't even understand this problem, to be honest. I'm gonna come back to all these problems, I'm not gonna lie. Is it sorted? It's okay, this problem might take me an hour to do. That's okay. I'm okay with that. Kind of. I am kind of okay with that. Dude, I just have no idea how to do this. And I don't want to do it. My brain just doesn't want to do this at all right now. But I need to do DP. Well, I guess for this one, I have 3 choices. If I do it reverse, right, I have 1. Let's do a black. It's bigger than black and white. Hold on, maybe it should be, I can go to 11. I can go to 7. And I can go to 2. So we can see that this is 1, 2, 3 coins here. But like, how do I do this? We can see this repeated step right here. 2, 1, 0, 2, 1, 0. The base case is that there's only one way to go from 0 to 1. There's also one way to go from 0 to 5, and there's one way to go to 0 to 10. Right? Because you can't be greedy. This isn't a greedy problem. That's the thing. Like this, it could be like if this number was 2 and then this number was 13, and you're like, oh, it's cooked. That's the problem. But I don't really know how to like code this up. Like I'm looking at this wonderful decision tree and nothing is happening inside my brain, if you get what I mean. That's the thing, though. That's the thing. I don't get it. Like, what am I? Like, what is this? Like 1, 2, 3. 1, 2, 3, 4. But like, how do I like do all the intermediary steps? That's my question. I don't get it. And it's like, do I want to get to 11? Like, from obviously, I need to go to 11. How do I do that? That's me right now because I don't fucking get it. He has glasses. What am I doing? I just have no idea how to like do I go from the bottom from 0 to 1? Like from 0 you can go to 1, 5, 10 in one step. You can go to 2 in 2 steps. You can go to 10 in 2 steps. You can go to 20 in 2 steps. But obviously 20 is higher than the amount, so you should stop there. But it's not like you can, that's just, like you can go to 11 in 2 steps. You can go to a lot of numbers in 2 steps. That's the problem. I don't know how to keep track. Dude, I just have no fucking idea how to do. I give up. It's been like 10 minutes. I don't even know where to start. Like he did the same thing I did. Okay, he did it from the top. Let's look at that at least. Let's try that. So look, 1, 5. This is like a little different than mine. 1, 2, 5. I go to 1 from here. I can go to 0 from here. Or no. I can go to 2 from here. But I already have a 2, so this is just a useless path or what? Like, oh, no, it's not 2. It's 5, 10. I can go to 2 from here. I can go to 6, and I can go to 10. I can go to 11. I can go to 3. Wait. I can go to 1 to 2, 1 to 6, 1 to 11. But I have 2 of these 11 paths. And look at all this repeated work, dude. But it's like, how do I store this 2, 6, 11, and 10? Like, this is 4 like different values that, how am I supposed to do that, you know? How am I supposed to store those? I just can't visualize this code at all. Nothing is appearing in my head. Like, do I just start with this array and then I like do some DP with it? That's probably what I do, but like, I have no idea. I give up. I don't know what's going on.
Another classic dynamic programming problem, coin change, and we get a pretty simple description. So we're given
Dude, these videos are fire.
coins
I love them.
of different values, and we're also given a total amount of money that we want to sum up to. But we want to use the fewest number of coins possible to make up or to sum up to that amount. And it's possible that that amount of money cannot be made up with any combination of the coins that we have, and then we want to return -1 if that's the case. And luckily for us, we're actually given an infinite number of each coin. So in the first example, we have coins of value 1, 2, and 5, and we have infinite quantities of these coins. The amount that we want to sum up to is 11, and basically, you know, just look at this. What's the fewest number of coins we could do? Well, of course, we want to use a 5 because it's the biggest one. We can use another 5, and then we just need a 1 left if we want to sum up to 11. So in this case, you can see we only needed 3 coins. This is the fewest number of coins we needed, so we can return 3. In the second example...
Wait, I think I know how to do it. Oh, no, don't look at the solution. Okay, I didn't see it, guys, I promise. Do I make an array of 10,000? Or not 10,000. I make an array of size amount. Okay? So 12 in this case. So then, if I go back to this example, there's one way to get to 1. Right? This is 0 indexed. So there's one way to get to 1. You need 2. Oh no, you need 1 coin to get to 1. You need 2 coins to get to 2. You need 3 coins. You need 3 coins to get to 3. You need 4 coins to get to 4, but you need 1 coin to get to 5. You need 2 coins to get to 6. Whoops. You need 2 coins to get to 6. You need 3 coins to get to 7. You need 4 coins to get to 8. You need 5 coins to get to 9. Is that even accurate? 5, 6, 7, 8, 9. Wait. 5 to 6 to 7 to 8 to 9. You need... Dude, I should have drew this. You need... This is 9. I should write out the index of indices. 1, 2, 3, 4, 6, 7, 8. You need 1 coin to get to 10. You need 2 coins to get to 11. And you need 3 coins to get to 12. This is the dynamic array that I need to build, or the DP array that I need to build. And so I populate it initially with these values. Or some shit, I don't know. So like I 1, 1, 1. This is all how it goes. But then how do I... What do I do? Like binary search on it or something? Like how would I know that this is 2? Like how would I know that there's 1 coin to get to here? I don't. All right, back to the video.
We have a coin of value 2, but we want to sum up to 3. We can try 2 plus 2, but we know that's 4, so we went over 3, so there's no way to possibly sum up to 3, so we return -1. There's no possible solution. So your first idea might be, can we just be greedy? Is the problem that easy? Can we just be greedy? And let's look at this example. So let's say these are our coins 1, 3, 4, 5, and we want to sum up to 7. So when I say greedy, I mean, okay, we want to sum up to 7. Let's just start at the biggest coin we have. So let's start at 5. So now let's look at the biggest coin again, 5. If we add a 5 here, we know we're going over the total amount 7, right? So we don't add another 5. Well, let's look at the 4. Well, we know 5 plus 4 is also going to be more than 7. 5 plus 3 is going to be more than 7. Okay, but we found a 1. Luckily, we have a 1. So let's add 1 to it. Now we're at 6. So let's add a second 1. Now we got to the sum 7. So we basically went down from the biggest, smallest coin values, right? That's what I mean when I say greedy. Let's pick the biggest one possible first. So notice that this took us 3 coin values, right? So our result in this case would be 3. But is that the minimum amount of coins? The answer is no.
Wait. Hold on. Going back to... Dude, I really want to solve it without the fucking video. Wait, I check for... So I'm at 1 coin. So it's 2 minus 1. Hold on, so the amount is 1, 2, 3, 4, 5, 6. Okay, so the amount is there, right? So if I'm here, so I'm out, this is 1, this is 1. The starting array will only have 1, 1, 1. Right? This is how the starting array is going to look like. Well, these are all zeros here. So if I'm here, right, and the amount is 2, right? I need to see if 2 minus the value before me is in the array. So if this value is in the array, then I know that I can just add it right here. Because then this puts a 2 here. And if I have a 3 here, I do 3 minus the previous index. So 3 minus, and then it's the same thing. So if I have this 10, right? This value of 10, and I'm like on this one right here, or on this like index, I'll do 11, because I'm at index 2, right? Or I'm at index 10, so which means that I'm looking for the amount 11, right? This blue one. I'm looking for the blue amount, right? I do minus the index before me, which is 1. So I have 1 coin, right? But I do minus 10 equals 1. And I have to look for this one in the array. That has to be how you do it. Right? Right, guys? Let's try to do it. Let's try to code that up. Before I look at Leetcode's stupid solution. My name is Leetcode. Hey guys, welcome back. My name is Leetcode. I'm Leetcode. Okay. DP equals 0 times amount. Okay. For num in coins, hold on. DP at spot num minus 1 equals 1. Print DP, return -1. Okay, so look, we got this beautiful Can I do a... Okay, let me do this problem on Leetcode, bro. Okay, if... for none in coins. Print dp. Oh, I have solved. Huh, me when I lie. I didn't solve shit. Wait, why would it be amount plus 1? Oh, I kind of remember how I remember. Man, I really just cheated though on this one. All right, I'm gonna try to do it my way. Can I do? So 4I in range of 0 to the len of dp. I guess it would be 1. It would never be... Can I also set... Okay. I'm really giving this problem my own shot at greatness, you know what I'm saying? Okay. If so this is 1. Two minus 1. Yeah, but where the hell did I get the 2? It's spot I minus... Okay, on dp at spot I is equal to... Hold on, if... No, hold on. If I plus 1 minus dp at spot... Oh my god, this is giving me AIDS. It's just giving me AIDS. Right, because I plus 1 minus... That's always 1. Oh my god. Please, brain. Come on, work for me, please. If I plus 1 minus something... It says 2. But it's always going to be 0 then. Or it's going to be always going to be 1. So if it's 2, then how would I... Oh, but that's in there though. Oh no, but it's not in there. You can't get to there. So I need to somehow... So if it's 4... I don't think my solution works. Because I don't know how to... There's like I'm missing a variable or something. Yeah, I don't know how to do this stupid ass problem, dude.
Because, just looking at it. So the next thing you might try is like a brute force solution, right? So to do the brute force solution, we need to implement some kind of depth first search or backtracking solution, right? So let's look at the same example, 1, 3, 4, 5, and amount sum to 7. So what would a backtracking solution even look like for this problem? Well, it's going to be brute force, right? So we have 4 coin values. So that means in our decision tree, we have 4 possible choices. We can choose a 1, we can choose a 3, we can choose a 4, or we can choose a 5. In this case, the remaining amount would be 6 because 7 minus 1 is 6. In this case, the remaining amount that we have to compute would be 4 because we're taking 7 minus 3, which is the coin that we chose. So we get 4 as the remaining amount, right? In this case, we would have a 3, and in this case, we would have a remaining amount of 2. So since none of these are 0, once we get to 0, we know that we've computed the total amount that we want. But right now, we have to continue going, right? We have to continue doing the brute force approach. Let's start at this side right now. So we still have 4 coins, right? We have unlimited quantity, so we can choose the coin 1, we can choose a 3, we can choose a 4, or we can choose a 5. If we choose a 1, we'll have a remaining amount of 1. If we choose a 3, we're going to get a -1. What does that tell us? That tells us if we chose a 5 coin and we chose a 3 coin, then we get to a negative value. That means 5 plus 3 cannot be the amount, so we don't have to keep searching here. We can stop, right? We got to a negative value. If we keep adding values to it, it's just going to become more and more negative, right? And you can probably notice that since these values are even greater, 2 minus 4 is going to be negative 2, 2 minus 5 is going to be negative 3. So we can't go down these paths either. We don't have to search them anymore. And so now here we're going to see, okay, we can choose a 1 coin. Of course, we can choose a 3, 4, and 5, but we can see from here that that's not going to work. That's going to lead us to a negative value anyway. If we choose a 1 over here, then we know we're going to finally get to a 0. So this is what we want, right? We took a 5 from up here, we took a 1 from over here, and we took a third one, right? So then if we count how many coins we chose down this path, we know we get 3 coins, right? And we get to a 0. So of course we don't have to keep searching anymore. So we found one possible way where we can sum up to the amount 7. We know it has 3 coins, which, you know, from the previous example, we know that that's not the minimum amount of coins, but we found an algorithm that at least tells us a possible solution. So we can kind of keep track of that. The minimum coins we can set to 3. So now I'm going to show you what happens when we go down this tree path, even though we know that the solution is actually 3 plus 4, which is 2 coins, which either of these is going to get us to the correct solution. I'm going to show you what happens when we go down this one anyway. So we can choose a coin 1, 3, 4, or 5. So if we go down this path, we will have a remaining amount of 5. Here we'll have a remaining amount of 3. Here we'll have a remaining amount of 2. Here we'll have a remaining amount of 1. Do you kind of see how we're taking the original problem, which is 7, and then breaking it down into sub-problems like 6, and then breaking it down even further
talks to me like I have a mental handicap.
5? And not only that, we have sub-problems,
breaking it down?
But do you
when we're going from
also
7 to
see
6, that is minus
these
1.
Sub-problems are repeating themselves. Here we have a remaining amount of 1. Here we also have a remaining amount of 1. So do we even have to compute this path? Because we already know if we have an amount 1, it takes only a single coin for us to be able to reduce it to the amount 0, which is what we're looking for. So since this subproblem repeats, I don't have to compute it. I can just borrow from over here. So in that case, we see the same thing happened though. We use a coin 1 and we get 0, and we see that, okay, it took 3 coins for us to get to 0, right? We took a 1, a 5, and another 1 from over here. So
I know how to do it. Hold up. Wait a minute. Okay, new idea. So basically, it's... So you start at the amount 12, right? The array is 1, 5, 10. So you start from this array here. So you know that there's, from 12, there's one way to get to 11. One way to get to 11. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's one way to get to 11. Here, let me just write the indices because this is confusing. Okay, there's one way to get to 11 because you subtract this 1. There's one way to get to 7, which is here. And there's one way to get to 2. 0, so 1, so right here. Okay? So now you're at, let's say like you're at amount 10, right? There's one way from 10, there's 2 ways. There's 2 coins you need from, because you have 1 coin here. So from 10 to 9. Or from 11 to 10. Hold on. Right. So from 11 to 10, you need 2 coins. Right? From 7 to 6, you need 2 coins. From 2 to 1, wait. You need 2 coins.
Basically, we got the same thing that
I gotta go in
happened
20 minutes,
over
bro.
here, just in a different order. And just to make this a little less messy, I'm just going to tell you that none of these are going to lead us to the optimal solution. So now let's look at this case. We have a remaining amount of 4. How many coins does it take for us to get an amount 4? Well, let's brute force it. Let's check every possible combination. Here we'll get a 1. Here we'll get the value we're looking for, 0. That's great, but let's just look at this last one. With 5, we'll get a -1, meaning we can stop searching. So this is awesome. We got a 0, and let's count. How many coins did it take us to get to this 0? We took 1, 4, and we took a 3, so this path is only 2 coins long. We see our minimum is currently 3, but we can actually replace this now with a 2, because 2 is the minimum number of coins needed to total to amount 7. So we know this is the correct answer, but let's just see what happens with the remaining stuff. So first, let me just look at this 1. We see we actually already solved this subproblem over here, so we don't really need to solve it again. We know it takes 1 coin for us to go from 1 to 0. And what about this 3? Okay, well, we can do the same thing, right? 1, 3, 4, 5. And I'll just tell you, from here, we're not going to find the optimal solution. Going from 4 to 3 and more, that's going to obviously be more than the current minimum of coins that we have, which is 2 right now. So this is not going to lead us to the correct solution. But you see that once we compute this stuff, then we have one last subtree over here, right? This original 3. But once we already solved the subproblems of this, do we really have to solve the subproblems here? No. If we store it in memory, if we have like a cache, or you can call it DP, we do not have to repeat these subproblems. So the way I just solved this was called top-down memoization, because we're doing it recursively, but you can actually solve this with a true dynamic programming solution, which is bottom up. And it means exactly what it says. So bottom up, basically, instead of solving the original problem where the amount is 7, we solve it in reverse order. We start at the smallest one, which is 0, right? This 0 over here. So we want to know what's the minimum number of coins. We can call it DP of 0. So for amount equals
Dude, I was
0,
on the right track. I just have no idea how to code it.
For us to sum to 0. Well, we know it just takes 0 coins, right? What about if we want to know what's the minimum number of coins for summing to 1? Well, we can look at our coins. We got a 1, a 3, a 4, and a 5. These will all cause it to be greater than 1, but we just want a 1, so we can take just this, meaning it only takes us 1 coin to sum to 1. And then we can just repeat that process, right? So for a DP of 2, so we want, how many coins does it take for us to sum to 2? Well, we got 4 coins, right? These 3 will cause it to be greater than 2, so we don't use those. But what about this one? Okay, we get a 1, so it takes 1 coin to sum to 1, but that's something we already knew. So if we want to compute
Dude, I was doing it
dp
right.
of 2,
Oh, fuck, dude,
we
I was
can
doing it
take
right.
1 plus dp of 1. Because we know these 3 coins are going to be too big, but we have a 1 over here that's value 1, and we also know that that's not enough, right?
I was doing it right,
2
bro.
2 minus 1 still leaves us with a remaining amount of 1, but we just computed that up here. We know for us to get the minimum number of coins to get a value 1, it only takes 1 coin. So that means that if we want to get amount 2, it takes at least 2 coins. And let's say we repeat this process for all values, for all amounts from all the way starting at 0 all the way to 7 over here. So I computed it from all the way from 0 to 6, but the last one we really want is amount equals 7. So let's compute that, dp of 7. How do we get it? Well, we still kind of have to check every single coin. So what happens if we get coin 1? Then we take the result of 1, meaning that's how many coins we use, not the value 1, because we needed 1 coin.
dp of 7 is going to be every coin, so it's like the value 7 minus the coin 6, which is 2, minus 3, which is 1, and then you just add them together
with a value 1, and now we have a remaining amount of 6, right?
Like this girl, bro.
6.
She's
so
cute.
how many coins
no cap, bro.
for us to
Claire is a baddie. Okay, I don't know
well,
what I'm saying.
We already computed that. It took 2, so we get 1 plus 2 equals 3.
Hope no one's watching
so that's
this.
One
My last video flopped, so
solution. But is it the minimal solution?
And no one's gonna watch
well,
this.
Well, let's look at if we use the coin
like who's about to watch me watch a
3
Leetcode video
over here.
You know what I'm saying?
Well, it takes us 1 coin, so we take 1 plus dp of 4 because that's the remaining amount we have to use if we take a coin value of 3. And luckily, we already computed dp of 4. It is 1.
Dude, so fuck, I only have 10 minutes, but I really feel like I can solve this without. Four. Oops. DP. If I plus 1 minus coin two yeah, that's gotta be it right there, bro. That's gotta be it right there. I'm not even joking. That's it right there. 3. Why is this 1? So I guess that's why this is 1, because it's just easier. You don't need to. But it would be 0, 1, 2. Well, how is it fucking... How is it 2? So 2, so it's 3. The amount of 3 minus coin is 1. Is it equal to 0? No. If dp at spot I plus 1 or I minus coin is equal to 0, continue. Else, what am I doing, dog? This is just super wrong. Expected -1. Yep. Fixed it. Solved it. Oof. Dude, just give me the freaking... Oh my god. Oh my god. You're giving me AIDS right now. I'm not even trolling. Wait, why? Oh, it's len amount. Bro, please, bro. Just give me the submission, bro. Bro, I'm gonna... Okay. What the fuck is the problem? Okay, I'm gonna come back from school and solve this problem. But I'm gonna not do it like this. I really thought I had it. I still think I like... Nah. Alright, well, I'll be right back, I guess. Gotta go to class. Ooh. Alright, what's good, gang? I'm back from class. And I'm tired. And I have homework. And I'm doing coin change. Let's just rewatch some of it because I kind of don't remember jack sleepers. Oh, wait, we're not even on the dynamic.
Have to solve the subproblems here? No. If this with a true dynamic programming solution, which is bottom up. And it means exactly what it says. So bottom up, basically instead of solving the original problem where the amount is 7, we solve it in reverse order. We start at the smallest one, which is 0, right? This 0 over here. So we want to know what's the minimum number of coins. We can call it DP of 0. So for amount equals 0, what's the minimum number of coins for us to sum to 0? Well, we know it just takes 0 coins, right? What about if we want to know what's the minimum number of coins for summing to 1? Well, we can look at our coins. We got a 1, a 3, a 4, and a 5. These will all cause it to be greater than 1, but we just want a 1, so we can take just this, meaning...
Oh my gosh, new comments on a video? Did you get the job today? No. Interview November 22nd. 6 minutes ago. I got him with the instant reply.
One coin
instant.
To sum to 1. And then we can just repeat that process, right? So for a DP of 2, so we want, how many coins does it take for us to sum to 2? Well, we got 4 coins, right? These 3 will cause it to be greater than 2, so we don't use those. But what about this one? Okay, we get a 1, so it takes 1 coin to sum to 1, but that's something we already knew. So if we want to compute DP of 2, we can take 1 plus DP of 1. Because we know these 3 coins are going to be too big, but we have a 1 over here that's value 1, and we also know that that's not enough, right? 2 minus 1 still leaves us with a remaining amount of 1. But we just computed that up here. We know for us to get the minimum number of coins to get a value 1, it only takes 1 coin. So that means that if we want to get amount 2, it takes at least 2 coins. And let's say we repeat this process for all values, for all amounts from all the way starting at 0 all the way to 7 over here. So I computed it from all the way from 0 to 6, but the last one we really want is amount equals 7. So let's compute that, dp of 7. How do we get it? Well, we still kind of have to check every single coin. So what happens if we get coin 1? Then we take the result of 1, meaning that's how many coins we use, not the value 1, because we needed 1 coin with a value 1, and now we have a remaining amount of 6, right? dp of 6. So how many coins did it take for us to compute dp of 6? Well, we already computed that. It took...
Man, I feel like I should be able to solve this problem, but I'm like stupid or something. Like, I don't know what's going on. Max number of test cases used, bro. That's how you know it's over. I think the issue is it's supposed to be the minimum. If I plus 1 minus coin. We need like min amount. Because it's like, right now, I think that's the problem right here. I don't know what the hell this is for. What was I thinking with this one? dpi minus coin is equal to 0. Continue. I'm just going to trust that. Then I'm going to need that. All right. So we got min underscore amount equals min of min underscore amount and dp at spot I minus coin. And then this is going to be like here, but it's actually going to be min amount. And that's just going to work first try. And I'm just going to submit it. And it's going to be so awesome when this works just first try. Like, isn't that awesome? Like, I'm done. Like, I figured it out. I actually understood. I came back from school. I thought about it. I came back. And fuck! Wait. If min underscore amount is equal to float in continue. Bro, can you just let me solve this problem? Like, I've actually been battling demons trying to solve this problem. Like, I'm not even gonna lie. This is the hardest Leetcode problem. Just give it to me. Let's go. All right, 28%. Now we get rid of this print statement. I mean, the print statement probably didn't even do that much. It was also this. 32%. We did it. I beat the coin change problem, kind of.
2. So we get 1 plus 2 equals
Let's just finish out this
3.
video out, and
so
then I'm
that's
gonna
one
call it
possible
a day.
solution.
Oh, I got
But is
3
it the-
Discord notifications. Oh my, I gotta check those. Yo, to anyone's watching this, I was just discussing my upcoming internship at, can I say? I guess I can say at Geico. It's not even like an insane company. That's the worst part. This actually just came out of nowhere, I'm realizing, because I just paused and unpaused. So the person watching this is like, what the fuck? What just happened? I was watching this guy do a Leetcode, and now he's talking about some, like, his own personal life. I don't know. I mean, people keep asking me in the comments about this. I mean, that's kind of my whole channel is the job. Got an interview with Geico on the 22nd. And guys, that was the last available time slot available because there was like some other reasons I wanted to do earlier, but I couldn't. So now I'm doing the last available time slot. And I'm just praying like they didn't just hire everyone already, you know, the head count or whatever. The head count hasn't been reached, or the goal for people. Because, man, at 200 Leetcode problems by now, and like I know there's not, I kind of know it's not going to be DP on the interview. So there's that. But also, man, I'm like at like 200, like 30 questions, bro. Like, and for Geico, seriously, for Geico, like, no offense, like I'm not saying like Geico is like it's a great company, probably. I don't know anything about Geico, but it's not like people talk about on Reddit. It's like, oh, well, I guess people are doing like 500 questions for Google, but there are people with like 300 questions for Google, you know, and I'm at like 230. I feel like I don't know. I feel like I got it, but I also feel like I don't got it at the same time. All right, let's just finish this problem.
Minimal solution? Well, let's look at if we use the coin value 3 over here. Well, it takes us 1 coin, so we take 1 plus DP of 4 because that's the remaining amount we have to use if we take a coin value of 3. And luckily, we already computed DP of 4. It is 1. So then we get 1 plus 1 equals 2. And we know that this is the real result that we want. But even before we know that, we would repeat this process. So technically, if we do the bottom-up dynamic programming solution, we are going to repeat this for the remaining 2 coins. So for 4, we would get 1. So we'd have 1 plus DP of 3 because 7 minus 4 would leave us with a remaining amount of 3. And in that case, we know DP of 3 is 1. So we would have the total of 2 again. So we see that there are actually 2 solutions. And we know we have one last coin that we technically have to check, coin 5. So we'd use 1 coin for value 5. And then the remaining amount we'd want to compute is DP of 2. And we know that DP of 2 is value 2, so this would result in a 3, which is not what we want, right? So from these 4 values that we computed, we want to take the minimum, which we know is 2, so we can return 2 in this case. So that took us forever, but luckily the code is a lot shorter. So just like
Man, I kind of want to see how he codes it, but I want to implement it myself first. Okay, I'm going to do it on his website first. I'm gonna watch.
A DP array, and
I don't want to enforce bad habits.
Initialize this to be length of amount plus 1 because we are going from
amount plus 1
0 all the way to amount. And the default value I'm gonna give each element in this array is amount plus 1, or you can do like infinity or whatever the max int is, like math.max integer or whatever in your language. But amount plus 1 is basically a max value anyway. And we know that the base case for this is the DP of 0, meaning if we want to compute amount 0, that it only takes 0 coins. And now we're going to start computing every value in DP. So for every amount A in range, and we're going to do this in reverse order, or rather bottom up. So we're going to go from 1 all the way to the amount.
Yep.
And we technically are still doing it in a brute force way. So we are going to go through every coin. So for coin in our list of coins, so we're trying to compute this A amount. So we're going to take A and subtract the current coin that we're looking at. If this is non-negative, so if it's greater than or equal to 0, that means we can kind of continue searching, right? So this means we possibly found a solution for our DP. So for this amount A, we're going to set it to the minimum of itself and 1 plus DP of A minus C. So this
so it's 1.
This 1 comes from this current coin that we're using, C, and DP of A minus C comes from, for example, let's say our coin value was 4 and our amount that we're trying to compute, A, is 7. Basically, we're saying DP of 7 is equal to 1 plus DP of 3, because 7 minus 4 is 3. So we're saying that this is a possible solution. And actually, that's the only thing that we have to do. This is basically it. This is like what's called the recurrence relation. And so now the only
How is that the recurrence relation, dog?
thing we have to do is return what we're looking for. So DP of amount. So this is what we have to return. But we remember one last edge case. If we could not compute the amount, meaning so we can only return this if the value that's stored is not the default value. So if it's not equal to amount plus 1, right, which was the default value that we gave it. So we'll return this if it's not the default value. Otherwise, we're going to have to return -1, meaning we could not compute this amount with the given coins. So this solution does work, and even though it's pretty efficient, the time complexity is actually big.
It's n squared, is it not? Or it's not n squared, it's A amount times length of coins.
So the amount that we're given multiplied the number of coins.
Yeah. Okay, let's just try to do this one more time, everybody. Let's do it on Leetcode website. I don't want to do it in Leetcode's shitty ass website. Just kidding. It's not shit. I know I said that. Okay. See, but he had it like, oh, he did amount plus 1 times amount plus 1. And then DP at spot 0 is equal to 0, right? Okay. So for amount in range of 1 to amount plus 1, for coin in coins, you gotta use like, okay. If amount minus coin is greater or equal to 0, DP at spot amount is equal to the min of DP at spot amount minus coin, right? Something like that. Yeah, plus 1. That's like low-key it, right? Return DP at spot, we'll do -1. If DP at spot -1 doesn't equal amount plus 1, else -1. Bruh. Can only concatenate list. What? Oh, wait, you have to do the, oh, bro, the PEMDAS. How could I forget, bro? How could I forget? That's embarrassing, honestly. Object int is not iterable. Oh, yeah? Oh, I forgot the other thing. And DP at amount. This 1 plus goes somewhere else. Right here. On some genius level S, bruh. Submit. There you go. Yeah, my other solution had me filling up DP before I even started, so. All right, well, that's going to be it for today. 2 hours and 20 minutes. Trying to get to 3 hours, probably like daily, because I want a job. I also just want to be good at programming, but that's another, you know, that's like not as cool to say. So that's going to be it for me today. I'm going to see y'all next time.